All right, guys, tonight, not necessarily. We'll take this exam Friday, but throughout the week, rthill3 at gmail.com. As the other night, last Thursday, I was sitting at the Gwinnett County Awards Banquet, Broward County Awards Banquet, and I got a text message from a student that I had last year. I don't know what I did this for her. She took a picture of the problem with her phone, emailed it to rthill3 at gmail.com. I answered it, sent it back to her, boom, boom, boom. Took about 45 seconds. I helped her work some problems on the final exam. She got stuck on something. Guys, anytime we can create a Google Hangout if you need a lot of information. I can create a thing using my iPad called ShowMe. If you go to showme.com, you can see there's all kinds of stuff there that can help you with that stuff. By the way, along that line this weekend I found a pretty neat new application, or I think it's an extension, to be honest with you, for Google Chrome. If you have an Android phone, you don't have to have an Android. If you use Google Chrome for anything, and you want to send information back and forth between your phone and the web, push bullet, P-U-S-H bullet.com. Good one. If you have a picture you want to send it to your computer you want to send it to your phone, back and forth, good way to do it. Files. What's really cool is you can message that way too. So if you know somebody's on their phone, but you're on a computer, send it to them. Pretty cool. Again, 1 through 16 are already done. 14, 15, and 16, I'm going to talk about that morning that we take it, because there's some things that I just kind of need to remind you of that day. But anyway, I'll pick up right here and stop the video in about 20 minutes, and we'll go to the lab. 17, what's the deal with 17? What has to be the same? Use my term. Use the term though. 2 by 2 minus 2 by 2, the dimensions have to be the same. Guys, once you get the dimensions the same, 4 minus 8, let's just work it out. 4 minus 8 is negative 4. Negative 7 minus 10 is negative 17. 10 minus 1 is 9. 10 minus 9 is 1. That's it. 2 by 2 matrix. Again, guys, just add, once you have it, eyes up here. As once you have two matrices that are the same size, once you have the fact that they're the same size, you just add the corresponding place. Again, that's matrix A, let's pretend like it's matrix A and this one's matrix B. So if I ask you where A11 was, that's row 1, column 1. If I ask you where row B23 was, B, row 2, column 3. This problem says it wants you to add them. So guys, you add the corresponding places. 2 plus 9 is 11. 4 minus 2 is 2. 0 is 4. 7, 10, 17. It's just adding the corresponding spots is all I'm doing. But they have to be the same dimensions. If they aren't the same dimensions, for example, number 22 here, you could not add it. Again, in number 19, does anybody remember what that's called? What kind of multiplication is it when I multiply every single time by negative 3? Keep trying. Keep trying. Guys, it's called scalar multiplication. That's scalar multiplication. When you multiply by a scalar out front, you scale every point, every matrix. Look, this could be matrix X, Y, Z. That could be coordinates of a triangle or something like that. And if you multiplied everything by negative 3, you increased its size by negative 3. And what would the negative do to it? Or excuse me, you increased its size by 3. And what would the negative do to it? But what does that mean? What would that do to a picture? Yeah, it would flip it. So this would flip and dilate. This would flip it and dilate it. I need to stop this or pause this.
Whoa.
All right, look, here in this problem, just brought to my attention 5 minus 4, or 5 minus 9, 5 minus 9 should be negative 4. Sorry about that. 20, add the corresponding places. Guys, it's 21. You can just add the corresponding places. That's 21 is the first one. That is a major problem. Guys, there are a lot of us in here that look at 21 and don't know what the process is that you go through to get that problem. Guys, it's not abnormally difficult, but you got to know what to do. Guys, this is called scalar multiplication, number 19, and this is matrix multiplication. When you do matrix multiplication, the first thing you do is you make a dimension statement. And the dimension of the first matrix is 2 by 2, and the dimension of the second matrix is 1 by 3. So when you make your dimension statement, the reason you're doing that is so you can figure out whether or not you can do it. Guys, there are people in this class that are going to spend 20 minutes on problem number 21 coming up with an answer. Y'all will use some of the most creative things to figure out a way to do that. But guys, it does not have an answer. Remember, when you do scalar multiplication, it's row times column, and you do the sum of the products. We all seem to understand, everybody in the room seems to have a good understanding that if we have an equation, and I take the coefficients, let's say A, B, C, D, and I take another matrix, B, and let's call it X, Y, and I take a third matrix, and let's call it C, and let's say it's E, F. Guys, if I do row, look at this, if I do row times column, if I do this row, if I do row AB times XY, I end up with AX plus BY. Because that's what it is. Row times column. AX plus BY equals E. Look, see this row times this column. CX plus DY equals F. Guys, that's what matrix multiplication is. So you end up with row times a column. But sometimes, guys, if the column of the first matrix isn't equal to the row of the second matrix, guys, you can't do it. And when you figure out a way to make something up, that makes it where you can do it, guys, the work that you're doing there is not correct. So this is that one you can't do. This one you can't do either. Look, they're just asking you questions you can't do. You cannot do this. I can't take this row and times it by that column. It won't work. 2 by 2 times, again, 1 by 3. Those numbers right there have to be the same. Now, when they are the same, like in this one, which is a 3 by 2 times 2 by 2, guys, remember the outside number gives you the size of your answer. So row 1, eyes up here. Row 1, column 1 has an answer. And it's sum of the products. So 2 times 2 is 4. Negative 3 times 3 is negative 9. 4 minus 9 is negative 5. So that first row by column gives you negative 5. Now do the second one. Now I'm going to take that black circle and multiply it by 4 negative 2. So first row, second column. So 2 times 4 is 8, plus 6 is 14. So this gives me 14. And now I just continue the process. Now I take the green line times the red. So row by column. 12 plus 15 is 27. 24 minus 10 is 14. 6 times 4 is 24. 5 times negative 2 is negative 10. 24 minus 10 is 14. Because that's what you do. Okay. Now I got the last row. So now I'm going to take 1, 4 and do the same thing. Again, guys, it's row by column, sum, what does sum mean? Of products. Sum of the products. 1 times 2 plus 4 times 3. 12 plus 2. 14. 1 times 4, 4 times negative 2. 4 minus 8. Guys, you're not going to, you guys, your plan is to not do anything and then pass the, guys, it's a bad plan. Because this is not majorly intuitive. This is not, you just look at it and you get, for those of you that just, you refuse to do any work, you better at least look at some matrix multiplication. Again, that's what this is. It's called matrix multiplication. This one's a scalar multiplication. Okay? Is the product of the following pair of matrices defined like yes or no? If yes, give the dimensions of the product matrix. Again, they're just trying to get you to do 1 by 2 and 2 by 2. Can you do it? Yes. The reason you can do it is because those numbers are the same. The size of your answer is 1 by 2. So this matrix, 2 by 1 times 2 by 1. Can you do it?
Yeah.
No.
No, because it's not the same.
Not the same there. Evaluate the determinant. Guys, you've got to know how to find the determinant. If you don't know how to find the determinant, guys, you're not going to be able to evaluate. Again, the way you find it is you cross multiply and subtract 48 minus negative 35. What is that, 83? Now remember how we found this matrix, or this determinant? We rewrote 2, 1, negative 2. Negative 1, 2, 1. We rewrote those columns. We rewrote the first 2 columns and then calculated what the diagonals were here, multiplying. So 3 times 2 times negative 2 is negative 12. 2 times 2 is 4 times 1 is 4. And so that's 0. So those numbers we subtracted, didn't we? We said these numbers were addition. So 4, negative 4, what is that? 3 times 1 times 1 and 3. So 3 minus a negative 8. Yeah, subtract these, subtract the ones you go to the left, subtract those, add these together. Subtraction in the middle. Find the inverse. Define the inverse. The first thing, the first thing you got to find is the determinant. Again, you got to know how to find the determinant. I can't teach you how to find the determinant in 30 seconds. You can't sit there, put your head sideways on your phone, and get how to find the determinant. But this question is going to be asked. And if you make a 40 on the final exam, I have a hard time justifying. I can get you when if you pass the final, it's helpful. Well, if you make a 30 on the final, there's nothing I can do to justify passing. You're taking it out of my hands. And your plan not to do anything and take this, guys, is not a good plan. Again, sitting there watching me find 1 over the determinant times the transpose isn't going to do you any good. You got to know what that stuff means. And the determinant is cross multiply and subtract. So 3 minus negative 14 is 17. Then you take 1 over 17. Why, Coach? That's how you find the determinant. You do the inverse. You do 1 over the determinant. And remember, the transpose is to take these two guys and switch them. You don't switch these two, but what do you do to them? Opposite. So negative 7 and positive 2/7. And then guys, look, this is just scalar multiplication. 1/17, negative 7/17, 2/17, and 3/17. Find 1 over the determinant, 32. 32 minus 63. Guys, if you don't know where I'm getting 32 from, or where I'm getting negative 363 from, this doesn't make sense. But all I'm doing is cross multiplying. And then I subtract. Why subtract? That's how you do it. So you get the answer. That's how you do it. You cross multiply and subtract. 32 minus 63, what is that? Negative 31? Times 8 times 4, negative 7 times negative 9. Let's multiply that stuff. 8 over 31, 7 over 31. I'm sorry, it's negative. 9 over 31, and negative 4 over 31. It's called the inverse. If I multiply the inverse times the original matrix, does anybody remember what it was I did? If I multiply this inverse by the original matrix, if I multiply A, matrix A, times A inverse, come on. You get I, the identity matrix, guys. I, the identity matrix, is a square matrix. A square matrix with ones across the diagonal. There's ones across the diagonal. As again, I'm going to go real quick. Let's find the x, y, and z intercepts. Simply means just take these, just take them and set them up equal to the answer there. So 2x equals 12 means x is 6. Guys, I asked you this the day we took this quiz on this stuff, and a lot of you missed it. If that's the x-intercept, what are the other two values? If the x-intercept is 6, what's y and z? 0. Yeah, 0. 6, 0, 0, 0. 3y equals, so y is 4, and then x and y, or x and z are zeros. So 0, 4 is 4. Remember that? 6, 0. 1, 2, 3, 4, 5, 6. Put a dot.
Oh, yeah.
Right 4. 1, 2, 3, 4. Put a dot. Z equals negative 3. So I go down 3. 1, 2, 3. This plane right here, this triangle is the plane. That triangle is this plane. But, yeah. That's different than when we did the points. Remember doing the points? That's right. 6, 4, negative 3. So 6, 4, negative 3. If I wanted to graph 6, 4, negative 3, I would go forward 6. Then I would go to the right 4.
Down.
Copy and paste it, put it there, connect the corresponding places. That's that point.
6, 4, right there.
That's forward 6, right 4, down 3. We went forward and backwards, front to back, right to left, up and down. That's the next set of questions. Forward and backward, right and left, up and down. This is a plane. This is this plane. This is the point, where that point is, the location of that point. Where was 0, 0, 0 in this room? Yeah, right there. Right there in the middle of the room. Not on the wall. None of this blue, red, green, because of what axis is what? This is the left and right, up and down axis. Front to back. All right, let's stop right here. Guys, watch this. If you have all your quiz stars finished, guys, when you get them up, go to take a snipping tool here, take a picture with your name on it. No, don't send it to me, just print it. File, save it, make sure it's got your name on it. Not copy from QuizStar. It'll say your name up there. Save it, print it. All right?